As you can see, we're looking at significant digits and calculations. This is a sheet you're going to look at, but I actually have it in PowerPoint form. So it'll go in the same order, but it'll just be a lovely blue PowerPoint. You have to get good at significant calculations. For over half the course, you're going to do calculations all the time. The rules matter, you should know why they matter, and you should know how to apply them. What you do have to understand is there's one set of rules for multiplying or dividing. They operate the same way, but a different set of rules for adding and subtracting. So we're going to start with multiplying and dividing, and that will tend to be what you do more of in chemistry in the early days. So it says round off computed results to the same number of significant digits as there are in the measurement factor that is the fewest significant digits. And you say, huh? Example time. Now everything's done for you. What we look at is here we had 5 significant digits, ST, significant digits. This one had 3. So we can't magically get more significant digits when we multiply or divide. There's 5, there's 3. It means we have to chop this to 3. It means you have to know how to round. Whoa. So we're going to go hi-ya, because that would have come in. Where's our hi-ya? Hi-ya. And look at this. We have a 9. Next to 9 is a 7. So 7 rounds the 9 up to a 0, which rounds that 2 up to a 3. And 23.0 is what we get. 3 sig figs here, 3 sig figs here. Proper chopping. Make sure you install the chop. Let's try another example. And the units will matter to us as well, but right now we're focusing on numbers. When we look at these measurements, we see this one has 2 significant digits because the 0 is a placeholder. This has 4 significant digits because none are zeros. Our calculator belches out this crazy number, and we say, hey, 2 sig figs, we got to go hi-ya right there. And so here comes our hi-ya. It came right in there. The 2 rounds down, so it stays at 7.7 kilometers per hour. Kilometers per hour. Again, units we'll worry about more later, but getting the right number of sig figs is what this is focusing on. We look at the third example, C. Here we have 4 significant digits. Here we have 2. Here we have 3. So our answer has to be rounded to 2. Here we had a 15.93. The 9 rounds the 15 up to a 16. You should know how to round from your years of math. Now we look at this one. Here we have 3 sig figs, but this 3 would be used in counting. It's saying we have 3 of these. And so it is not considered to be a measurement, so we don't put 1 sig fig. Our calculator comes in. Hey, we didn't get a hi-ya. There's our hi-ya. Comes in. And we see the 8 rounds the 4 up to a 5, so it says 48.5. 3 sig figs here. 3 sig figs here and 3 sig figs here. Now, adding and subtracting are different. And whenever you get a question, adding and subtracting, you should line things up vertically. It makes it so much easier to see what you're doing. So when you do adding and subtracting, sometimes you'll actually feel like you're adding sig figs. Technically, you're not. It just has that appearance. So this is a terrible way to write it out. We should write it out vertically, like this. Now what we see is, we know this number to this point, to the nearest thousandth of a centimeter, but we only know this one to the nearest tenth of a centimeter. So we got to do a different kind of hi-ya, and we do the hi-ya right here. It means we get this big answer, let the calculator do the work, 10.252, but now we're going to chop in the 10th position. Those 5.2, we can't account for them because the second measurement wasn't precise enough, didn't deal with it. So we look at 10.2, we see the 5 rounds of 2 up to a 3, And so we get 10.3 centimeters. It's all about place value in this game for adding, subtracting. Again, we should write this out vertically. So much easier if you do it that way. So we know things for this one, only the nearest hundredth. It's our least precise measurement. And so we're going to go like that, and I've got a better chop coming in right now. Oh, that was a thing of beauty. Let's see if I can get rid of that. Boom, 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 boom. Beautiful. And the 3 rounds down, so it's going to come out as 9.11 kilograms. If you put an answer down like this, that would be totally offensive. Maybe in math they love it, but that is just a disgusting thing to do in the world of science. So it's got to be 9.11 kilograms. Alrighty, so we got a bunch of things going on here. So we got our adding, our subtracting, and we know this is the nearest hundredth, nearest thousandth, nearest tenth. We got to chop our answer nearest tenth. That's the key thing. When you write out vertically, boom, boom, boom. This was our least precise one. We had no digits out here. So that 7 is going to round the 4 up to a 5. And we get 212.5. Rounding fives. We got to round to make the last digit an even number. This is not that big an issue. We run into it from time to time. In physics, they always round up. In chemistry, always round to make things the even digit. So here we have a 5. It's next to a 2. And so we are going to say, hey, we got to keep that at 212. And if we were rounding at this point, so let me just put these things in here. So that's going to be 212. Let's say I'm rounding here. Well, I got to make this digit even, so the 5 rounds that up to a 4, so it'll be 0.044. So there we are. So 43.35 becomes 43.4. So when we look at this, we are rounding and we're making that 3 even, and so the 3 rounded up to a 4 right in that spot. And we have to round here, and we said the 5 rounds it down. Again, out of all the things, I wouldn't spend a long time worrying about that stuff. Worry about the earlier stuff, multiplying, dividing, adding, subtracting.